Steve. Hi there. Everyone hear me all right? Yeah? Cool. So I am standing between you and lunch right now, so let me be quick. But first, introductions. So my name is Cliff Moon. I work for a company called LinkedIn. You may have heard of it. And I'm going to tell you about some of the work today that my team has been doing. In particular, we've been adding performance visibility to our A/B testing platform. Some introductions here. I've been on the performance team at LinkedIn for almost 5 years now. Before that, I have been involved in the observability and monitoring world for about 10 years or so, maybe a little bit more. And I've been in various startups, having co-founded, CTO, VP-Eng, everything in between. So yes, I've been around a while. And also, I work remotely from the woods of Western Washington. So I feel right at home here on the stage. This actually looks quite a bit like home. Since I work remotely from the woods on a farm, I figured instead of the usual stock photos of people in the office, I'll show who's in my office a lot of times. Not actually, but you know. Okay, so a quick note up top here. As with all large, projects that come out of large companies or things that come out of large companies, we have problems that may not exist at much smaller companies. And so don't just go and implement this. Like, think clearly about the problems you have. A lot of what I'm talking about are problems born out of scale. Not just scale in terms of like how many requests we get or the data we're working with, but scale in terms of like how big our engineering team is, how much change and churn is going through the code base. That being said, I hope, even if this is not a problem that you might have, I hope that the approach that I sort of put forward here on how to do research and how to apply it is something that maybe you could bring into your own practice regardless. Okay, so I want to talk a little bit about my team and what we do. So we have a team as part of performance in LinkedIn called SiteSpeed. And as part of SiteSpeed, we measure and monitor performance from the perspective of the member, right? So anyone who uses LinkedIn on a device, on the website, anytime you interact with LinkedIn as a part of the public, we instrument the performance from your perspective. So how long does the page load take? How long does the page load take? How fast do you get results on your screen? And so this is very much what you would call like real user monitoring, right? And we call it, and the highest priority metric for us is that PLT, the page load time, which is our proxy for how fast do you get results. So we maintain libraries for all the developers inside of LinkedIn to instrument their code. We track this performance by something we call page key, which again, as a matter of scale, how do you split up performance in a really large website like LinkedIn? Page key is what we use to kind of narrow down on various pieces of ownership. So a page key roughly proxies to a team somewhere in LinkedIn. So thinking about things like feed, messaging, all the various parts of the website that you interact with, that's owned by a team somewhere. And then we give them a fine-grained ability to see page load times for the piece that they own. We do aggregations on these metrics. In particular, we focus on P90. We've all heard about percentiles here this week. I think math is kind of a theme at Monitorama this time. So we focus on 90th percentile in particular because obviously averages lie. We all kind of know that. Response times do not adhere to a normal distribution. And so when we enforce SLAs against these page keys, we do so via P90. We have what we call regression tracking, and then this is really just our SLA enforcement mechanism. So we have automated systems that, once the page is in breach of its SLA, we open tickets against those teams, and then we give them help and support in helping fix those problems, helping get their page back into SLA, making sure we're giving a good experience to the LinkedIn members. So we also have an A/B testing system or an experimentation system. It is called Lix. It's a fully internal tool. but I just want to introduce it because what I'm going to be talking about today kind of dovetails in with it really closely. But as an experimentation tool, it provides a lot of support for things like dark launching, feature flagging, so pushing out new code or new behaviors into the website or into various platforms as part of the stack. It gives reporting on broad business metrics. So this is going to become important later, but essentially there's reporting tooling in there, but really it focuses on business metrics. So things that you're clicking a button, or like funnel activation and things of that nature. So metrics that adhere to a normal distribution. And so a lot of the reporting on whether or not an experiment is moving a metric is all based around, is it a normal distribution? Are you moving an average of a business metric across the entire site? And for reasons I'll explain in a little bit, that doesn't really work for performance. Yes. So I kind of want to introduce the problem that we set out to solve. Here's some stats about experimentation at LinkedIn. As I said, we have a pretty large scale engineering team, and because of that large scale, there's a lot of stuff going on. On any given day, there's over 500 active experiments. So small experiments to large experiments, new functionality being put out there. Any kind of experimentation you can think of, it's going on any given day. So there's a lot. And then, when we take a look back through the regressions that we maintain as part of the site speed team, what we found was a high percentage eventually root cause down to an experiment. We see that a piece of code got pushed out through an experimentation, and it caused a performance regression. It caused that P90 to slip. It caused us to breach SLA. And finally, there's a lot of parts of the website. We have over 1,000 active page keys. Many of them are very small pieces of functionality that don't that don't get a lot of traffic. Some of them get a majority of traffic, but there's a lot of page keys in the data, and so we need to support as large a slice of that as possible. So all this is to say is that we have a data set with high cardinality, a lot of dimensionality, and what we want to be able to do as the site speed team, we wanted a way to spot performance problems early. Monitoring page load time, monitoring RUM data. One of the things we find is that, if you remember Adrian's talk from yesterday, a lot of times these distributions that come in, a lot of times the measurements that happen, it's really hard to just looking at the measurements you're taking, it's really hard to even just say, hey, did something change, right? You think about seasonality of traffic, Monday through Friday. You think about all the various things that might be happening around the world, on a social media site, it's like, is there a conference going on somewhere? Is there an event happening that's putting this particular pop having more traffic? It's more saturated. There's so many variables that go into our data set because it's a global data set. That is really difficult to be able to look at a graph of P90s day by day and say, you know what? Yep, something has gone wrong here, and I know what it is. It's very, very difficult, and so we have a sort of a built-in kind of bake time that happens where you need to observe the performance for a page, that P90 performance over several weeks before you can definitively say something has changed and then kick off an investigation. So then say we breached SLA. The goal that we had was, hey, let's speed that up, and the way that we're going to do that is we're going to focus on experimentation. And as these experiments get pushed out to a small percentage of public members, can we say if it's going to have an effect once it goes out to everyone? So I embarked on this quest to kind of figure out if we can do this. It was last year, and one of my first questions was, how am I going to compare two quantiles? There wasn't a whole lot of literature around that. And so what I did was I was like, well, it seems like there is a lot of literature on comparing distributions. Maybe that might be useful. So that's kind of where I started my research. And let's talk about research a little bit. So I think one of the most exciting things for me as a software engineer is you have an open-ended problem. You do not know how to solve it. You've never encountered it before. So how do you even go about doing this? Like where do you even start? And I've done this a couple of times in my career. It's not often that this happens, but when it does, it's very exciting. This is kind of the methodology that I've come up with for doing research and how to apply it. And I'm not a researcher, I'm not a mathematician, I'm a software engineer. I need to apply things. So that's kind of what I'm gonna focus on. But sort of the methodology I follow is, one of the first things is you got to find the terms of art for the domain you're looking at. So what I mean by that is like the people who talk about this stuff, the people who devote an academic career to doing a particular thing, there's ways that they have of talking. There's like just keywords, search terms. There's ways they have of talking about their domain that you may not even know. And so how can you even search without the terms of art? This is kind of a bootstrapping problem of, you start searching around and you start looking at papers, and then you follow the citations. And by following the citations, you can sort of bootstrap your knowledge of the terms of art, the domain, how people think about the problem, and to start to, develop your model of how to think about the problem. So one piece of caution that I have, though, is that, I've read a lot of white papers in my career, and one of the things you kind of see is that, there's a lot of what you see in a white paper, you need to kind of read between the lines. Because, a white paper almost never comes with code. They talk about results that they get. You might see a table of data that came from a piece of code somewhere. They almost never publish the actual code. So you gotta ask yourself the question of where did it come from? Who published this? Is it academic? Is it from private companies? Is it, a combination of the two? When they talk about the system, do they talk about it being in production? Or do they talk about having sort of a research test harness? You really kind of need to understand how they applied this and if it's actually being used in anger as opposed to, just sort of research code that got made to just have the white paper published. And I think the final piece here that I think really helps when you're trying to apply research to a problem is you need to find ways to really quickly test the things that you're reading, the methodologies you're taking in, to try to see what's going to work and what's not going to work, and very quickly throw away the things that will not work. So I'm going to talk about how I kind of did that. So, how did that, okay. Sorry about this. Where did my, hang on. Sorry, I gotta go back to Chrome here and try to pull up, here we go. Are you kidding me? All right. You know what? All right, I gotta do this real quick. I'm so sorry. Apologies to everyone. It's gonna sign me out right in the middle of the presentation. Okay. Yeah. So I will talk a little bit about what was on that slide. So, as I mentioned, one of the first things I ventured to kind of research was, okay, comparing two distributions, right? What does that look like? So there's a lot of research in that vein, and there's a lot of different methods for comparing, in standard data science. Yeah, like in the standard kind of data science literature, there's a lot of really kind of tried and true methods for doing that. So there's, I think it's called the KS test. Yeah? Okay, cool. Yeah, got it. Yes, there's the KS test, Earth mover's distance, which sounds really cool. All right, we're going to reload all my images too. Excellent. Okay. Of course, we're going to do...
This is not an unfounded hate, is it? I'm not being irrational.
Okay.
I asked the question this year. If you work for Google, can you please DM me in the Slack? We're fixing this thing. Awesome. We're good.
All right, cool. Yeah, sorry about all of that, folks. Okay, yes. Yeah, all right, we're just going to go to this one. Yeah, so anyways, I went through a lot of different methodologies for trying to compare to two distributions. None of them would work. And I didn't really even understand why. But what finally sort of cracked the code was I finally found this paper from a data scientist at wish.com. And you can go and look this up. I'll post links in the talk channel. But this was like my breakthrough moment, finding this particular blog post, which is like how Wish A/B tests percentiles. And I'm like, oh wait, that's what I want to do. Cool. But I dug into it, and so one of the reasons why comparing two distributions didn't actually work is this right here. So in an A/B test, you think about statistics, right? Like all of our statistical methods are based upon the idea that when you're taking a sample, it is a fully randomized sample. In an A/B test, the way A/B tests are structured, that is not true, because my measurements are page load times, but the randomization unit is the user, right? So a user is going to have many page load times, and those page load times are going to be highly correlated with the particular situation of that user. So in other words, if you have a good internet connection, then you're going to have lower page load times, and they're all going to be correlated for you as the user. Whereas someone who is at a conference is going to have slow page load times, and they're all going to be correlated as well. And so this breaks the fundamental assumption of pretty much all statistical methodology. So one of the primary challenges to get over is how do you control for this particular for the randomization unit. I'm going to talk a little bit about how we actually do that. Oh my God. Anyways, the white paper. There's another white paper that's actually referenced, and my images aren't loading for some reason, but sorry about that. Anyway, here we go. Perfect. So there's a white paper referenced from the wish.com that actually is a white paper published by LinkedIn in 2017, I think. I'm like, wait a second. Okay, someone else solved this problem for me. That's great. Where's the code? Like, where is this? And this is actually one of the most interesting parts of this is that, usually as an outsider, you don't have the access to be able to say, like, where's the production system? Like, you published a white paper. Where's the thing that's actually running? I'm in a great position here because, like, I have the rare opportunity to actually see, hey, where's the production system that ran this? So, yeah, so I was reading between the lines here, and I'm thinking, okay, where's the actual code for this? And so we have some really good internal code searching tools. I was able to find this internally inside of our code searching system, and then I was kind of like an aha moment. I had actually dealt with this before, and I had no idea what it was. Like when I first got it, when I first got to LinkedIn, this is one of the things I had to fix because what had happened, it turns out what had happened was that the team that did the research, they implemented this as kind of a black box step inside of our data pipeline framework, and it was kind of done as a one-off. And so it was only ever used by the SiteSpeed team, and it, eventually, over a period of time, all the people involved with it kind of moved on to other things. And it became bit rot, right? So it started to break. And by the time I got to it, it was this kind of odd, broken thing. No one knew what it was based on. No one knew how it worked. So we kind of had to start over, and we just didn't know what it was. So it's kind of one of these interesting things of like, I mean, thankfully they published the white paper so we could rediscover it. But yeah, it's kind of wild. I was like, oh, okay. Yeah. But anyways, we decided, okay, this kind of worked before. I think this should work again. Let's go through it. So now I want to kind of talk to you about how does it actually work. So we're actually going to dig into the math here. So this is going to look a little intimidating. And I think a lot of mathematical notation is intentionally intimidating. But I want to hopefully kind of break this down for you a little bit. And so the methodology here, so let me kind of back up for a second. What we're trying to get to is that if I'm trying to do a statistical test on a percentile, and the percentile is just a summary statistic from the data set, right? What I really need in order to plug it into something like a z-test is I need the variance of that summary statistic. If I can get the variance of the percentile, then that's going to give me everything I need to plug it into the rest of like known, well-trod statistics in order to get my answer of, did this percentile shift in a significant way? And so what this is doing is that we essentially what we need to do is we need to generate a whole bunch of summary statistics from the data set, from each bucket in the data set. We generate our summary statistics, and these summary statistics really what they're trying to do is, remember what I talked about the randomization unit? Most of this is controlling for that randomization unit. So what we do is we find our P90. So the paper talks about P95, but in our case, it's just you just choose another quantile and it works. But essentially, we try to sum up. We try to get the counts and the sums for fast PLTs, so those that are under that P90 cutoff, and then we get the overall counts for these things. And essentially, like again, I don't have a deep understanding of the math, but intuitively, we combine them together at the end to kind of get the variance, and then that variance, it really just controls for sort of that bias in the selection of the users. So, yeah, and so we implemented this. This is actually the Spark code. This is part of the Spark code that runs this, and you can kind of see what it's doing here, right? Is that we're up top here. We're getting a window of quantiles. That window of quantiles allows us to estimate the density of the curve. So we're sort of like getting a numerical integration of the histogram, and then we're also getting our summary statistics down here. And it's just a really simple. I mean, it's pretty straightforward. Like once you again get through the mathematical notation, which is why I wanted to show the code. We're just aggregating this. We're just doing group bys, and we're aggregating all of these different sums of like PLT count, traffic count. And then we're getting, the PLT count squared, traffic count squared, and then, PLT count times traffic count, et cetera, et cetera. And so, and what these PLT counts are is these are the fast ones, right? So this is the stuff that was faster than P90. And these all mix together in such a way that we get, these all mix together through this equation in such a way that we get the variance. And it's really, and again, looks really complicated. It's actually pretty simple. We're just multiplying some things, dividing some things, adding some things. And in the end, sausage comes out the other end, and what we get is the variance of the percentile. So again, looks super intimidating, actually pretty straightforward once you dig into it. So yeah, what we ended up doing was we went back through, and so coming back to like, how do you test these things? What's the validation? And one of the nice things about LinkedIn is that we have raw data going back for a certain period of time. And so I can go back through historical examples of real life experiments that went wrong. And then I can run these methodologies through a very lightweight test harness to be able to say, hey, is this going to work or not? Would this have caught this incident early in the ramp? And what we found is that it was a resounding yes. We were getting very good signal from historical analysis. And the other thing we started to compare against was the gold standard, which is the bootstrap method. I probably don't have time to go into the bootstrap method, but essentially, like you think about variance, right? Like bootstrap is kind of the brute force way of getting the variance of that summary statistic, where you do several hundred rounds of sampling out of the raw data. You calculate your percentile, and then that set of percentiles, like each round you do, you get this set of percentiles. That will conform to a normal distribution. You can take the variance of that from that normal distribution, and then ta-da, there's the variance of your percentile. That's the gold standard. Unfortunately, it doesn't scale because you got to do several hundred rounds, and this adds up very quickly in the data pipeline. So anyway, yes, we validated this. We found that it worked. And then I got the green light from management to go ahead and build it. So now the rubber meets the road. Like, how do you take research and turn it into a product? Because you get really excited about this stuff, and you're like, this is going to change the world, this is going to be amazing, we're going to do all this stuff. But it's very, it's very easy to get sucked into the idea that you've got to build this enormous thing, you're going to change the world first, in the first go round. So what we decided to do was, let's let's narrow this down to a very, very small set of use cases and try to provide value with, just the bare minimum. Try to get it done in a quarter kind of thing. Like let's just get something out there. And it's funny because you think in a big company everything has to be built to the nth degree. No, the way you innovate in the real world and in public, same way you innovate in a big company. You got to get your stuff out there. You got to get in the hands of users. So what we decided to do was focus on a very simple use case for the developers at LinkedIn. Like I said, there's this page key ownership model. And this ownership model allows us to be able to find the teams for these pages. And we just built a notification system for them. Right? Every single day, we take a look at all the new experiments that are coming online within the past however many days. We take a look at new experiments. We do this methodology. We do the statistical testing on them, and we can tell them with a high degree of certainty whether or not their experiment is having an effect on that page. And the cool part about this is that this is kind of the foundation we've decided to build further work on top of, because once we get this small list of pages that we know are having an effect, we can then start to do more expensive calculations, right? So if you think about stuff like, okay, you've told me my PLT has shifted because of this experiment. That's great. What next? How do I root cause that? And so what we want to be able to do is we want to be able to do the same type of statistical analysis on all of the metrics that are happening. And think about the distributed trace. Think about all the services involved. Think about all the phases that happen in the browser or in the mobile app. We want to be able to zero them in, have automated root cause detection, to be able to tell them exactly what changed and with their experiment, so they can fix it quickly before it impacts a majority of our members and before it gets in the way of their development cycle. Makes them faster, makes the members happier, makes the website faster. So everyone wins. So yes, so the conclusion here, again, you might not have this problem. You probably don't have 500 experiments per day. I hope you don't. But this may be useful to you, but even if it isn't, I hope at least my approach to doing this kind of research and applying it can be useful towards you. And I think that the last point here, I really want to hammer home, you really got to be biased towards results. Your job as a software engineer is not to produce research. Your job is to solve problems and produce working systems. And at least in our case, at Monitorama, our job is to make the lives of the developers a lot easier. And so, that's what biasing towards results means to me. You gotta get it out there, get it in the hands of users. And so finally, this was a big team effort. I'm the only one who was able to come out here, but I really wanted to give a shout out to the teammates who did, honestly, the majority of the work. I'm just kind of the talking head. Tin, Abhijit, Pawan, Saurabh, great team of folks, and they did an awesome job building this. So thanks, guys. Yeah.
I feel like I'm living vicariously through Cliff because he's got this really awesome hobby farm, and when you're in tech, every once in a while you're just like, I should just farm, but turns out actually a little bit of work, right? Yeah.
Yeah, it's a lot of work, but I also do tech too, so it's I just have double work.
Double work. Awesome. Any questions here for Cliff before we start our break? I got a question right here.
Are you using the results of that to gatekeep, as a gate for full rollout?
Are you using the events as a gate for a full rollout?
Oh, that is an excellent question. So that's kind of some of the further work that we're doing. I kind of adapted this talk from a talk I gave inside of LinkedIn, so it was a very difficult question for me of what's actually relevant to an audience that's not internal. But yes, we're working with that, the experimentation team to do that kind of integration, to be able to essentially have it be a guardrail metric, so that you block ramps at certain percentages or roll it back if it's extra egregious. So we're working up the heuristics for how the decisions get made that way and automate them. Yeah.
Question right here. How do engineers at LinkedIn answer the question, what changed? That is a great question.
I think that's kind of the heart of this work, right? Is that as I mentioned earlier, we look at least on the site speed side, we look at a global data set that has so many variables in it and so many dimensions in it that it is incredibly difficult to be able to say what changed, again, without that period of time to see the shift in trend. You know what I mean? So what we're trying to do now is we're trying to focus in on these particular use cases where it doesn't cover 100% of everything, but we're focusing in on particular areas where we know change has been introduced, right? And so it kind of turns the problem on its head. So instead of looking at a global data set and saying what changed, where we know what changed. We know that an experiment happened and that a feature dark launched. So the question is no longer what changed. The question is, hey, this thing changed, did it do something? Did it have an effect on the metrics we care about? And that's an easier question to answer than what changed. That will not get everything, but again, it's a matter of you can't boil the ocean. So focus in on the heavy use cases, and that will automate away a lot of the pain.
Great question. One right here in front.
Yeah, you mentioned some of your page keys don't get exercised that often. There may be like a page that doesn't load right up. How do you approach sort of the challenges of trying to, what does it mean to have a P90 of a page that only loads like once a week or something like that?
Yeah, what does it mean to have a P90 of a page that's rarely loaded?
Yeah, that is a very insightful question, and it is it's a question that we ask ourselves on my team quite a bit. We don't have good answers for it right now, but it is something that we're trying, because you're right. There's parts of the website where performance still matters because they're for maybe they're for people who are paying and et cetera, or maybe there's all sorts of flows. And I got to be careful about what I say, but there's all sorts of flows through the system that might not be exercised so much, but the experience still matters. We do not have amazing answers to that right now. But it is something we're kind of actively thinking about, how to address those use cases without throwing away all the other stuff we built. It's a tough problem. Yeah.
There was one right here. Yeah, right here.
So I kept hearing the theme of great white paper, where's the code? So I'm going to ask, great presentation, where's the code?
Great presentation. Where's the code?
Yeah. You got me. I mean, that's kind of the thing, right? Is that how should I put this? You ever seen the movie The Gods Must Be Crazy, where it's about it's like a weird 70s movie, but the essential idea is that an airplane's going over like an undeveloped area. They throw a Coke bottle out of the window, and then some folks on the ground pick up the Coke bottle, and it throws their entire world into disarray. I kind of feel like large companies do this a lot. Of here's this incredible piece of technology. We're from the future. Ta-da, and then no one knows what to do with it because they don't have the context for that technology. I'm trying not to do that, and so that's why I'm trying to focus on more generic of here's how you do research and apply it. Here's an actual research methodology. I think that it's fairly straightforward to take the white papers I've referenced, and I'm going to put them in the chat to actually go and implement them. I can't open source the code that we have to do this because it's entirely too context dependent. There's an entire world of data pipeline frameworks that go with it that simply would not make sense in another context. So it's something I'm sensitive to, and you're right, you got me. I wouldn't be, it's like, do I do this talk? Do I not do this talk? How do I make it relevant to this audience? I hope I tread that line, but maybe I didn't, and that's fair criticism.
Awesome. Any other questions for Cliff? Wave your hand wildly. I can't see it. Awesome. All right. Oh, wait. Oh, you got in under the wire. I was almost going to say.
I was just curious how often you see interaction between, do you ever see confounding aspects because of interaction between experiments that are happening simultaneously?
Do you see confounding aspects of interactions between experiments? That's actually really interesting.
Another, incredibly insightful question. Yes. There is some internal affordances inside of the experimentation framework for doing that on purpose. So in other words, if you have an experiment that has to go along with another experiment, there's ways of forcing it to go and do that selection. But yes, interactions are possible, and especially on lower traffic pages. So we have, internally in the system, we have some traffic cutoffs where the numbers simply won't make sense. So it just won't work on others. So we just don't support it. But there's also other issues where you know, if you have an experiment that relies on some aspect of the user, right? So if it's like only premium users in this market, and you know, if you have a very like finely grained targeted experiment like that, there will be bias in the experiment itself, and so that's where you got to be kind of careful of, you know, is the experiment itself setting up bias? We don't have a great answer for that right now. You know, this work is getting us from, we have a table of tens of thousands of numbers to look at, to we have a table of maybe, you know, 20 numbers to look at. And we're going to get further, but it's already been like a leap. but yes, that is a problem we want to address. We just got to do some research to figure it out.
Great. Round of applause for Cliff and his goats.